Thank you very much for introduction, and thank you very much for invitations. And my talk today is joint work with Professor Dinh and Sun Yu. He's in China. And today, I talk everything is over a complex number field C, and I'm interested in smooth projective varieties. And question I'd like to discuss today is a very simple one. Is automorphism group. This is a biholomorphic automorphism group, and is finitely generated as a group or not. Of course, this is not true. For example, you consider a complex torus, then you have a continuous part. So dividing out continuous part, that is identity component of the automorphism group. Then this is, become a countable group. And so it makes sense whether or not it is finitely generated or not. Of course, if it is uncountable, never become finitely generated. And this is a basic question I'd like to discuss today. And actually, the theorem I'd like to discuss today is the following. This is with Professor Dinh and myself and Sun Yu. This is, we are now writing, and first manuscript made last week, but I hope this is okay. For all integer, here I put greater than or equal to 3. There exists smooth projective and rational T. Rational means this is birational to projective space such that dimension x is n, and it's discrete. This means identity component is just identity. So this is already countable group and non-finitely generated. This is one of the main theorem I'd like to discuss today. And in this theorem, this is maybe fast. And today I'd like to discuss mainly on this one, but for just to make complete, actually for or if X is smooth projective, alrighty, such that is finitely is not finitely generated, then I can show that Kodaira dimension this is maximal dimension of the image of pluricanonical linear system. This is smaller than or equal to n minus 2. In other words, cannot be maximal largest two values. And conversely, 3 for all kappa so except these two there exists X smooth projective and kappa X is given kappa such that is discrete and not finitely generated. This is result of what we obtained so far, and of course. The question itself is quite a natural question when we have a group such that this is a countable group, whether or not this is finitely generated or not. This is quite a natural question, and in algebraic geometric setting, this automorphism is rather natural to consider. But actually, such answer is quite recent, except very non-trivial case. If dimension 1, then question is yes. This is because one-dimensional case X is either P1 or elliptic curve or a curve of general type. And P1 case, automorphism group is same as identity component, and both are just fractional linear automorphism, PGL to C. And complex torus case, if you consider universal cover, then automorphism group is just translation and extension by a finite cyclic group. So also true. And general type case, it is well known that automorphism group itself is finite. So it is finitely generated. And also, then dimension 2 is natural. And in this case, and I can prove this, but I don't know who is the first to state this theorem. But anyway, we can show that is finitely generated unless, except these two possibilities. Possibility one is x is rational, i.e. x is this is smooth projective. Birational to P2, or second, x is non-minimum and Kodaira dimension is 0. More precisely, this case is slightly more precisely, x is just non-trivial blow up of K3 surface. K3 surface is by definition simply connected surface whose canonical boundary is trivial, or enriched surface. And enriched surface is by definition fundamental group is order 2 and its universal cover is K3. So essentially just quotient of K3 surface by fixed point free involutions. And this one can prove this by going using classification of surface and general type case using finiteness of pluricanonical representation shows that automorphism is finite. And kappa 1 case we have canonical fibration over a curve with elliptic fibers, and using this kind of structure we show that this. And so if we have some canonical fibration, then for the same reason this is always finitely generated. And finally, if not rational, then we can reduce to this case. And if this is really minimum, then for such a surface we have very strong Torelli type theorem. And Torelli type theorem says that it is finitely generated. So remaining case is these two cases. And this is already known, I think, long time ago. And people who are interested in this problem after this theorem consider the case where X is rational surface, whether or not one can make non-finitely generated automorphism group can be realized or not. But this question is still open, and quite so negative direction. This is surprisingly quite recent. And this is, first one is, this is certainly breakthrough result, and this is 2018. And he constructs, there exist some smooth projective, and in his case dimension is 6, and actually X is birational to 4-dimensional rational times of general type. So this case, Podaire dimension is minus infinity, but x is not rational. But it's discrete and non-finitely generate. This is first breakthrough, and I had this talk unfortunately not here, but overall puffer from him, and then he and Daniel Hoybrit asked me how about surface example one can construct or not. And fortunately, after I came back to overall puffer, Professor Dinh visited me for to work as a subject, but we talk about this problem, and fortunately we can solve second one. This is Dinh and me for all n greater than or equal to 2. There exists a smooth projective and n, and so this is now, and is discrete, and so at least the first answer for any dimension, because n is 1, I already say that the question is affirmative, so only counterexample exists if n is greater than or equal to 2. But in some sense, this gives first answer for all possible dimensions. And both of this construction, this is built from some S tilde smooth projective cases. Such that there exists some smooth rational curve and point such that SP. This is biholomorphic automorphism of S, which preserved the point P. And similarly, if we wrote SC, this means automorphism of S, which preserved the curve C, like this. Then, if automorphism of S preserved P, then this is a very special assertion or assumption. This is necessarily preserve this curve C. We assume this. Then, if this is true, then we have natural representation to automorphism of this automorphism restricted to C gives automorphism of this, and inside here we have P, and such that T, slightly, I omit some intermediate part. Consider that this is automorphism, and P and curve C is preserved. So tangent space at P of C is also preserved, and assume that action is identity. Then this part goes to just translation automorphism of P1, because infinite point is preserved and also tangent direction is identity. So this is, and this is abelian. This is one of the important part. And then I consider here image. I put this is G. This is important group G. RCG. This is now subgroup of abelian group. So this is again abelian group. And second assumption or assertion is that this is assumption also assertion. B. This is image contained this is an additive group C plus. This additive group contains additive subgroup generated by this fractional numbers. But clearly, this group is not a finitely generated group. Of course, countable and not finitely generated. Because denominator become larger and larger, so we cannot find finitely many denominators. So this is not finitely generated, and this is just subgroup, and usually just subgroup, some subgroup is not finitely generated does not imply larger group is not finitely generated. But here abelian, so this is again not finitely generated. And here to here is surjection. So finally, this should not be finitely generated. This group G is not finitely generated if we have these two very idealistic assumptions. And actual idea is realize G as V. There's different manifold as O to V, such that up to actually, I should say that there is a fact that if this is a subgroup, and if this is a finite index, then G is finitely generated. If and only if H is finitely generated. This is a purely group theoretical fact, and according to this fact, if we can realize this as and implicitly assume this is also discrete. This is not so difficult to make discrete. Then we can find some manifold whose automorphism group is not finitely generated and discrete. And going back to Lejutra's case, he started from he chooses such S as rational surface, and for example, if we have this, and for example, to make to make this as real automorphism, what is a possible way? One possible way is just blow up at this point P. Just blow up at this point of P. Then this automorphism group certainly linked to automorphism of blow up. But one point is that in general, there are some other unexpected automorphism comes in after blow up. So rational surface case, this certainly happens. For example, in rational surface case, if we choose 8 general point, and blow up them, and finally last 9-point blow up, then automorphism group looks like rank 8 abelian groups, model Bay group. But on the other hand, 8-point and different 2-point, then we can make so-called example of jiggle disk. And this is Professor Bedford, Kim, and also Professor McMahon construct this kind of example. And completely different automorphism appears. But for K3 surface, and the one advantage here is we start from K3 surface, then we make blow up, then the automorphism of K3 surface is of course naturally considered as birational automorphism. And this is also naturally considered as birational automorphism of the minimal model. But very essential part of classification of surface is that minimal surface in the sense that K is nef. Automorphism group and birational automorphism are coincide. So after blow up, we can control this as automorphism of original minimal surface, and this works well to get this kind of result. This is our first idea. But on the other hand, in order to do such a things, we start from minimal one. But if it is minimal one, then it is almost impossible to get rational manifold examples if we choose product and so on. And in order to prove this kind of, in order to get this kind of examples, we need to start some rational surface examples. And but to get maybe probably has to start and so from S is rational surface and need and make a suitable product and blow up. Such that this G and give all and this is the most difficult part and produce no new. We try to do this kind of things. Then finally, product and blow up manifold get almost whose group automorphism is G. We realize G. And what we did not yet, pardon? Fine? So, and here, I'm sorry, I assume this is n is greater than or equal to 3. Why n become one lose is that actually, so far, maybe Professor Dinh already find good idea. So far, we cannot avoid these product steps. And the product steps makes at least dimension 1 higher. This is so far essential reason why we restrict to dimension greater than or equal to 3. And before forgetting, I just state this is still open. And probably in this direction, most major question is that is there smooth such that and non-finitely generated. As a second talk today, day by day, I also confuse this may not true and this should be true, but I have no definite feeling about this problem still. This is open problem.
So let me see. Here you're talking about there exists, let me see. You said built from
this one. This is and rational. This is we want to make rational examples.
Yeah. And so it seems to me, what's the difference between that and the open question?
Open question is surface dimension 2. N is 2 is only missing. This is Kodaira dimension greater than or equal. More precisely, this is something x is birational to K3 surface times general type. So this is far from rational.
Oh, I see. I thought you said, okay, this one here is a
yes.
K3.
Yeah. And so, in order to get rational example, starting from rational is important. And yes. And I should also say that for if we don't care about Kodaira dimension and so on, once we get to surface examples, then general type manifold automorphism group is finite as by pluricanonical representation. So if we take this kind of product, automorphism, if in addition we assume K is very ample or ample, then automorphism become product. So if this is non-finitely generated and this is part is just finite group, so we can automatically get any higher dimension. But for rational surface, rational manifold case, even if we construct rational surface examples, but if we product like general type manifold, then this is not become rational because rationally connected fibration is not is based on this general type manifold. So even if we construct rational surface examples, to construct higher example is still non-trivial. And one part of our proof shows that there is some way to construct from rational to higher dimension. This is the main part. And rest of my talk, I give some idea of proof. Top. Thank you. Now, sorry. And to do this, I first record slightly more detailed structure of reduced surface and start from surface. And this is certain blow up at intersection of 6 lines in P2. So we have 6 lines, then intersection point is just 6 times 5 divided by 2 is 15 point. But slightly choose these 6 lines slightly more special one. And this is there exists smooth rational surface such that this is actually a proper transform of this, but this I don't need it. Just one effective surface, and this is discrete. This comes from construction. Actually, representation of non-stable is injective, and G is this group, and satisfies assumption A and B. In this case, curve C can be chosen one of the proper transform of this, and point P is chosen that just intersection of blow up point of the chosen point. So this is.
What did you just now say? You said you're telling us how to choose the 6 lines?
Yes, yes. This is just 6 lines in P2. And then, so it's not so easy to write down 6 point precise intersection. Anyway, then we have 15 intersection point, and we can just blow up. And one condition is that none of 3 are collinear. None of 3 of collinear. And another condition to make this, I also assume this is one line, and then for this one line we have other 5 lines, and they intersect, and intersection point is 0, 1, 2, 3, and infinity, which is like this.
You mean if you parameterize the line by P1?
Yes, P1, and just choose this point, then we can realize this number. This is not very important, but I'm sorry, I forgot to say that also real home problem, this choice is important, but I just remark at the end of talk if I have a time. Anyway, just for non-finitely generation, it is not so important. Anyway, so we have nice group G as above, if satisfy this. And point is how to make how to realize this as a finite automorphism group of higher dimensional rational varieties. And in order to do this, as I told already before, that for general type case, we can consider pluricanonical representation, finiteness of pluricanonical representation can be used to show this kind of things. But here, no pluricanonical, because this is rational world. But instead of this, we have anti-canonical representation. In good case, we have anti-canonical representation. And of course, this is automorphism invariant. So we can use somehow this kind of things. And another important thing is that this is V is Delpech surface of degree 2 or 3, which is and just finite generation problem. This is not really important, but real form problem this is crucial. But anyway, then automorphism group of V is finite. This is a classical factor and actually not so difficult to prove. Again, we can just consider this representation and finiteness. We can easily show. Anyway, we start from this. And then maybe just odd case. The even case I return back to later. And let S residual. And also consider P1. Then we make Z0. This is S times P1. And we have here SCP. And here we have P1. And for later use, I choose 3 points. And here we have, one tangent direction. And here we have also another tangent direction, which is like this. This is all what I need. And then first take G. This is blow up at P infinity. So here I have exceptional divisor, which is we have this exceptional divisor over P infinity. This is like product of this, and just intersection point we have blow up. And then next blow up at so this times this point is not included here. So this is just inverse image of this point is still 1 point. And finally choose this is inside in the tangent space of this. This and this is tangent space inside here. And then we make projective wise class of this tangent. We have this. Blow up at these 3 points. And this I put G2. This I put G2. And then
theorem
is that this is a smooth cubic. This is, of course, rational, smooth rational. And dimension is 3 plus 2L. So all possible odd dimension greater than 3 is possible, greater than or equal to 3 is possible. And odd, this is I put X. It's discrete. And non-finitely generated. This is actually our theorem, and even dimensional case, choose of P1, choose V. This is derivatives of degree 2, and then we have ramification, and 1 point, we choose 1 point and take W as normal bundle. Normal bundle of the ramification divisor at 1 chosen point. And we make the same construction then. And finally, I prove why this gives our examples. And first of all, this odd times this is S times P1 times Vi. This is actually equal to odd S times odd P1 times. We can prove this. This is because this is X. As I told you, we consider this. This is just by Cunness formula plus D. This is a fixed component. And this part is very ample. So gives this vibration, and this is preserved by auto X. Because coming from this is the important part, and this is preserved by auto, and so this act on. So from this, it is not so difficult to say that automorphism is something like this automorphism, and here also some automorphism, but this depends on the base. But automorphism fiber is discrete, so does not depend on the base, and we get this. And once we have this, the next and we have also P2 to X. This is Z0 times P1 times. We consider this kind of non-constant map. Then, because, sorry, this is S. Because P2 to S, there are no map. P2 to P1, no map. P2 to each cubic surface, we have no map. So this must be, for each factor, it is constant. So this map is all constant. But then, sorry. But then, P2 goes to here. Then, because we have here to here, we have here to here. So, but then this means non-constant image is just inside E times fiber, E times of Vi. So this is again preserved by automorphism of this one. So and finally to I, then non-constant image is inside, we choose this. This is fiber E1 plus 5Vi, E minus 1 plus I, and E infinity times, E times. We have this and fiber of So in this way, all automorphism control exceptional locus. So in this way, out X preserves exceptional, and then go back to, can go back to out I, and then after that this is finite. Using this part is finite. Reduce that to G is just actually index 2 of the automorphism of G2 times pi vi, which is our X. And we already see that this is non-finitely generated, so this automorphism is non-finitely. And in this way, we conclude the result. And the important part is to blow up, and P2 can be controlled well. But if just blow up S, then only P1 appeared. But S is rational surface, a lot of P1s. So this is, at least for me, still difficulty to reduce dimension 2. Thank you very much.